In this video, I'm going to show how to find the shaded area right here using Google Sheets and also JavaScript. Here I have the function f of x equal to 0.5x squared minus 3x plus 5, which is the graph, this graph right here. And then I want the area between the x-axis and the graph from 1 to 6. So here's the yellow region again. And so to approximate the shaded yellow area here, I'm going to divide it into 10 rectangles like this, and then find the area of each rectangle, and then add the 10 rectangles together, and that will give us the an approximate area for the shaded region. So right here, this is 1, and then this is 6. And then I'm dividing it, the interval from 1 to 6, into 10 sub-intervals. So this point right here, this will be x of 0, which is 1. And then this is x of 1, which is 1.5. X of 2 is 2, all the way up to x of 10, which is 6. And then to find the area of each rectangle, I'm going to use what's called the midpoint. And so the first sub-interval here is from 1 to 1.5. So the midpoint right here will be 1.25. And then to find the area of this rectangle, we need the height of this rectangle here. And so the width of the rectangle is 0.5. So to get 0.5, we just do 6 minus 1, which is 5, and then dividing by 10, and that will give us 0.5. And then to get the height of the rectangle, then we need to evaluate this function right here with x equal to 1.25. So in the place of x, we would put 1.25, 1.25. And using, this is Google Sheets right here. This is what it would look like. Here's the first sub-interval, x, this is 1, this is 1.5, and so the midpoint is 1.25, and then this is our function right here, and then in the place of x, we would put 1.25, and then evaluate, and it will give us 2.03125. And then if we go to the next sub-interval right here, which is for the second rectangle right here, it's going to start at x equal to 1.5 to x equal to 2. So 1.5 to 2. So the midpoint would be 1.75. And again, the width of the rectangle is still 0.5. And so to get the height, we would do f of 1.75. So in the place of x here, we would put 1.75, and then evaluate, and then we get 1.28125. And then so on, and then we would do the same thing for the other 8 rectangles. And then if we add the areas of the 8 rectangles together, of the 10 rectangles together, we get 8.28125. So the area of the shaded region here, yellow shaded region, is approximately 8.28125. And now what I like to do is show how I generated this table right here using Google Sheets. And so this table here, we can generate it using Google Sheets or Microsoft Excel. We'll get the same thing. And so the first column here, I have the sub-interval here. And so here's the first sub-interval, the second sub-interval, and then the 10th sub-interval. And the first one, the first sub-interval is from 1 to 1.5, and then the next sub-interval is 1.5 to 2, and then the last sub-interval is 5.5 to 6. And then the midpoint, then we just add these two values together and then divide by 2. To get the 1.25, we can do equal, and then we want to do this cell plus this cell, and then dividing by 2. And it'll give us 1.25. And then we can just copy this formula right here, which is F9 plus G9 dividing by 2. And so Control C, and then we just paste it. We just paste the formula to the other 9 cells right here, and then we'll get similar formulas. And then will give us the midpoints for each the midpoints of the for each sub interval here. And then to get the f of x sub I, or the function value evaluated at the midpoints. And so to get this value of 2.03125, then we need to replace x with 1.25. And so we're going to do equal. And then we're going to use this function right here. So it's going to be 0.5. And then right here, this is 0.5 times x. And so we have to use the multiplication sign. We don't put a multiplication sign right here, and then Google Sheets won't know what to do. And then we want 1.25, which is in cell H9, and then the exponent 2 here, we just do hat 2, and then minus 3, and again this is 3 times x, and so we have to say 3 times, and then again x is 1.25, and then plus 5. And then will give us f of 1.25. And then we just copy this cell right here and then paste. And then will give us the height for each subinterval, or the height for each rectangle right here. And then the width of each rectangle, again, it just b minus a dividing by n. So in this case, it would be 6 minus 1 dividing by 10. In the 0.5, and all rectangles have the same width. The area of each rectangle is just going to be the width times the height, or the height times the width. And so right here we would do equal, and then the height times the width. And it will give us the area for the first rectangle. And then we can copy this formula and then paste, and then it will give us the areas of the other rectangles. To get the area of an approximate area for the shaded region, what we need to do is add these areas of the rectangles together. And so we want to add these values together. Then we're going to type sum, S-U-M, and then we want to sum these values right here together. And it will give us 8.28125. And next, what I like to do is, instead of dividing the shaded region into 10 rectangles, I'm going to divide it into 100 rectangles. And then I'm going to show how to generate a table like this. And so here's the yellow region here. We have 10 rectangles. And so I'm going to increase the number of rectangles to 100. So the sum of the areas of the rectangles is going to be 8.3328125. And now I'm going to show how to set up the table on Google Sheets to get the sum of the areas for 100 rectangles. And we will notice the following. Once again, delta x, which is the width of each rectangle, it just could be b minus a over n. And so if n is 100, then be 5 over 100. If n is 10, then be 5 over 10. But notice that x, the first one here, this is x sub 0, x sub 1, x sub 2, x sub 3, x sub 4, and so on, all the way to x sub n. X sub 0 is just going to be a plus 0 times delta x. X sub 1 here would be just a plus 1 times delta x. X sub 2 would be just a plus 2 times delta x. And so x sub I will be just a plus I times delta x. And then the left endpoint for the first interval would be just x sub 0, and then the right endpoint would be just x sub 1. And then to get the midpoint, just like before, we just do x sub 0 plus x sub 1 dividing by 2. And so here's our table again on Google Sheets. And so this is A, which is in cell E4. And then this is B, which is in cell F4. And then N, this time be 100, which is in cell G4. And then delta X would be just the formula B, which is F4 minus cell E4 dividing by cell G4. That will give us 0.05. For subinterval 1, this will be x sub 0, and this will be x sub 1. And so x sub 0, I'm going to do a plus 0 times delta x. So equal, and then cell E4 for a plus, and then for 0, I'm going to do 1, the subinterval number minus 1. So the subinterval minus 1, which is 0, and then times, now delta x is going to be cell H4. And then I'm going to copy this cell right here and then paste right here for the rest of the cells under column F right here. But the thing that we need to notice right here, A will remain constant. And so this E4 right here needs to be constant. So I'm going to insert the $sign in here. And then the delta x right here is also needs to be constant. So I'm going to insert the $signs in here. And then copy. And then paste. And so this is x sub 0 in this column here. The right endpoint is going to start with x sub 1. And so x sub 1 is the a plus 1 times delta x. And so right here I'm going to put equal. And then cell E4 for a. And then plus 1, which is the subinterval number right here. 1, and then times delta x. But again, I need the a's to stay constant, so I'm going to put the $sign here to make it stay constant. And then the delta x, same thing. I want it to stay constant. And then copy, and then paste. And then now we have the, for each subinterval here, we have the left endpoint, we have the right endpoint, and then the midpoint would be just the left endpoint plus the right endpoint dividing by 2. And then copy and then paste. And then next, we need the height of each rectangle. And so we're going to use the function here and replace x with the midpoint value. So equal 0.5 times, and then the midpoint, and then again the exponent 2 here is going to be hat 2. And then again, this is time 0.5 times x. So we have to use the multiplication sign right here. And then minus 3 times the midpoint, then plus 5. So this is the height of the first rectangle, and then we're going to copy this formula and then paste. And then the width of the rectangle, which is the delta x right here, then I'm going to copy but first I need to make this constant. And then the area of the rectangle, it's going to be the height times the width. And then copy, and then paste. And so now the areas of the rectangles will be in cells K9 through cell K108. And so to get the sum of the areas of the rectangles, then we need to add the values in column K. Sum of the areas in column K right here, I'm going to type sum equal, and then sum, and then K9 through K108. So for 100 rectangles, the sum of the areas of the rectangles is going to be 8.3328125. So that's how we would create a table for 100 rectangles. And then the next thing, what I like to do is automate this table right here with JavaScript. So that way when we change the number of rectangles from 10 to 100 to 1,000 to 10,000, then we just call the JavaScript program to generate this table for us. And to automate this table right here using JavaScript, we would go up here to Extensions and then click on Apps Script. And the Apps Script window will open like this. And so the first thing we need to do is to write function, and then we need to give it a name. And so in this case, I call it area under curve sheet 8. And then the first thing, and then the next thing we need to do is to identify the name of the sheet that we are working on. And for this table right here, I'm using sheet 8. And so the name of my sheet here is sheet 8. And so we would go back to our function right here, and then we would write it like this, and then sheet 8. And then the next thing, I need the value of a, b, n, so that we can calculate delta x. So a, I'm going to call it AA, is located in cell E4. And so we would write sheet, which is sheet 8 right here, dot get range, and then the name of the cell, which is E4, dot get value. And now the program will read this cell E4 here. And then similarly, we will get the value for B, which is in F4, and then the value for N, which is in G4. And then we can calculate delta x, which is b minus a over n. And then I'll come back to this variable area under curve in a few minutes. And then this is our function right here. And so when we do slash, this is just a comment. And so here I have a for loop that runs from 1 to n, which is the number of rectangles right here. And then the sub-interval, the first one is a 1 here, and so that's what I have right here, and it's located in cell E9. And so I'm going to do sheet plus get range, and then E, and then I is 1. So the first iteration is 1. So I'm going to do I plus 8, which is 9. And this will be E9 for this 1 here. And then in E9, I'm going to write the value I, which is 1. And then for the first sub-interval, the left endpoint will be A plus 0 times delta x. And so that's what I have right here. And then I'm going to write this value in cell F9. And so this will be F and then I plus 8, which is 9. And then in this cell F9, I'm going to write the value x left. And then we need the right endpoint for the first sub-interval. And so the right endpoint will be A plus 1 times delta x. And then I'm going to write this right endpoint right here in cell G9. And so here I have G, and then I is 1. And so it would be plus 8, which is 9. And so now we got the left endpoint, we got the right endpoint. We can calculate the midpoint. We will do the x left, which is the left endpoint, and then plus x right, which is the right endpoint, and then dividing by 2. And then I'm going to write this midpoint for the first sub-interval here in cell H9. So it's going to be H and then I plus 8, which is 9. I'm going to write in this cell the midpoint. And then the next thing we need to calculate is f of x of I star, or f of x of 1 star, which is the midpoint for the first sub-interval. Now the function is 0.5x squared minus 3x plus 5. And so in the place of x, we're going to put the midpoint, which is 1.25. And so we have to write a formula so that we can place it in here. And then Google Sheet is going to evaluate the formula for us. So the formula right here, I'm going to call it fx formula. Is f of x equal to 0.5x squared minus 3x plus 5. And we need to replace this x right here with the midpoint. And so I'm going to do this. And then in the place of x, I need to replace it with x midpoint. In Google Sheet, the exponent 2 here, we have to write it as hat 2. And then minus, and then 3, and then it's times x. And so we have to put the multiplication sign there, the star. And then xm. And then plus 5. And then same thing here. If we don't put the multiplication sign right here, then Google Sheets won't know what to do. And then, so this is what we want to, this is how we want to write the formula right here. But notice that if we look at this formula right here, everything is fixed except for xm. And so to write the formulas where x of m changes, we're going to break this up into several strings. And so we're going to break it up like this. Semicolon. And so when we run the program, the formula is going to look like this: 0.5 times 1.25, and then hat 2 minus 3 times 1.25 plus 5. And then Google Sheets is going to evaluate this formula right here, and it will give us 2.03125. And then to place this formula right here, this formula in this cell right here, and then which is cell I9. And so that's when we would do sheet dot get range I and then 9 right here. And then it's going to place the formula in there. And then to calculate and then the next cell right here, this is just the width of each rectangle, which is a constant, which is the same, all widths are the same. So it'll be just 0.5. And to place the 0.5 here in cell J9, and then we would write sheet.getRange in J, and then I plus 8. We're in iteration 1, so 1 plus 8 is 9. Dot set value, and then delta x. And the program is going to place the value of delta x in cell J9 when I is 1. And then this last column here, which is the area of the first rectangle, then we need the height times the width. The height is currently in cell I9. And so I need to get this value right here. And so I'm going to call it fx, and then sheet dot get range I9, and then get the value. So get the value in cell I9. And then the width is just delta x. And so the area of the first rectangle be just fx times delta x. And then I'm going to call it area ith rectangle. And I'm going to place it in cell K9. And then our for loop here is going to run from 1 to 10. And so it's just going to repeat the calculation here all the way up to 10. And then what we need is the values of the area. We also need the sum of the areas of the rectangles. So we also need to add these values right here in the last column. And so the way I did it here is I'm going to start with area under curve equal to 0. And then each time I'm going to do area under curve equal to area under curve plus the area of the rectangle. And so when the for loop is complete, the area of the under the curve is going to be the value of the sum of the value of these 10 rectangles. And then here I ask it to place the area under the curve here in cell J4. And so J4 is going to be right here. And so we'll get 8.28125. And the next thing I want to show is to create a button like this right here, find area, so that every time I clicked on it, then it's going to run this function right here to generate the table. Because here I have 10 sub-intervals. What if I want 100 sub-intervals, or 100 rectangles, or 1,000 rectangles, and so on? And so to create a button like this, we would go under Insert, and then click on Drawing here, and then click on Shape, and then we want a shape, any shape we want, and so we want rectangle. Then it's going to create this rectangle right here, and then just write Find Area, and then click Save and Close. Then it's going to create a button like this, and we can place it anywhere we want. And then what we need to do is assign a function to this button right here. And so go back to our function and then copy the name of the function. So copy, and then click on the 3 dot right here, and then assign script, and then paste the name of the function. And so every time we click on this button, it's going to run this function right here. So for example, I'm going to change this to 20, and then I will click find area, and so now it's going to generate a table with 20 sub intervals. And then the sum of the area of the areas of the rectangles is going to be 8.3203. And then if I change this to 100 and then click find area, then it's going to divide the interval from 1 to 6 into 100 sub intervals. And then it's going to generate a table with 100 sub intervals. And so here we get 100 sub-intervals right here. And then the sum of the areas of the rectangles is going to be 8.33. And so the exact answer here is going to be 8 1/3. And so as we increase the number of sub-intervals, this value right here is going to approach 8 1/3. And then the last thing I want to say is after you write this JavaScript function right here, this is the save button right here. So you need to click save. If you don't click save, then when you run it from over here, and then it's going to say error or something. And so after you finish the program in here, click save and then click run. When you run this program for the very first time, you might get a message from Google Sheet. It's going to say authorization required. And so just click on review permissions, and then it's going to say verify the account. And then next, you're going to get a message like this. And so click on advanced, and then click on go to Untitled Project, and it's going to run the program. And that's the end of the video. And so that's how we would use Google Sheets and JavaScript to find the area under the curve right here.